This EBS experiment has been designed to demonstrate the performance of engineered barrier systems and evaluate their design and technical feasibility. The experiment is being conducted using a full-scale engineered barrier system installed at a depth of 350 meters below ground level. For the engineered barrier system experiment, a new 25-meter-long tunnel named Test Niche 4 was excavated. This tunnel branches off from a loop tunnel located at the 350-meter level. A test hole was excavated in this new tunnel, followed by the installation of buffer blocks and a model overpack. After that, the test niche was backfilled and sealed with a plug. To monitor what's happening in the system, sensors were placed in the test hole and the test niche. Let's take a look at how the experiment was conducted. A hydraulic breaker was employed to excavate the test niche. Excavated rocks were temporarily stored at ground level and used to backfill the niche. Rock supports were installed at 1-meter intervals. The wall of the niche was reinforced with low alkaline concrete developed by the Japan Atomic Energy Agency. A newly developed large-diameter excavator was used to excavate the 2.4-meter diameter by 4.2-meter deep test hole. The excavator is capable of performing both the full-diameter casing drilling and the auger drilling. This allows for efficient construction without causing the surrounding rocks to become loose. Water injection pipes and sensors were installed at the bottom of the test hole. Buffer blocks, one of the components of the engineered barrier system, were then placed in the hole. The buffer blocks were made from a mixture of 70% bentonite and 30% silica sand. The mixture was press molded into both fan shapes and cylinder shapes. The fan shape was made by dividing a ring into 8 equal pieces. The cylinder shape was designed to fit into the center of the ring. These blocks were stacked in 12 layers so as to enclose the model overpack. During the installation of the buffer blocks, the applicability of a vacuum gripping device was studied. While placing the buffer blocks, various sensors were also placed in the test hole. An overpack is a part of the engineered barrier system that prevents groundwater from contacting the vitrified waste inside. The actual weight of the overpack, including vitrified waste, is approximately 6 tons. In this experiment, a heater was used instead of vitrified waste in order to simulate the heat generated from the waste. In addition, a weight was added to simulate the weight of the actual overpack. The surface temperature of the model overpack was controlled throughout the experiment. After installing the model overpack, the top of the test hole and a part of the test niche were backfilled. The lower part of the test niche was filled with backfill material to a height of 1.4 meters. The material was spread and compacted using a hand guide roller. The backfill material consisted of a mixture of 60% waste rock with 40% bentonite. Backfill blocks were placed on the compacted backfill layers. The blocks were press molded from the same bentonite and waste rock mixture that was used in the backfill layers. Approximately 8,700 blocks, weighing a total of 130 tons, were used to fill the niche. Water injection pipes were installed to distribute water throughout the backfill. A plug was constructed using low alkaline cement to isolate the system from the outside. The tubes and cables from the measuring instruments led to the outside via a pass-through duct. The duct was filled with caulking material, bentonite, and silica sand to ensure a watertight seal. Finally, the preparation was completed, and the engineered barrier system at Test Niche 4 was ready for the experiment. At this point, the heater was turned on, and the monitoring of the system performance was launched.